Ladies and gentlemen, welcome to this Audioslides presentation. I am Alexander Semenov. For the next 5 minutes I will discuss our recent paper entitled Searching for a BNP Standard. Glycosylated proBNP as a common calibrator enables improved comparability of commercial BNP immunoassays. The paper was published in Clinical Biochemistry Journal. B-type natriuretic peptide is widely accepted as a useful and cost-effective biomarker of cardiac function. Recent clinical studies suggest that absolute plasma BNP concentrations measured by various immunoassays differ substantially. This complicates interpretation of results and renders the cutoff concentration method dependent. One of the reasons for the lack of equivalence between existing BNP immunoassays is the absence of a common calibrator. The purpose of the present study was to compare several BNP-related proteins to determine a form that could be used as a common calibrator to improve the comparability of commercial BNP immunoassays. In our study, we tested 6 different external calibrators, 2 forms of BNP, synthetic and recombinant, produced in E. coli, 2 forms of recombinant non-glycosylated proBNP, produced in E. coli, and 2 forms of recombinant glycosylated proBNP, produced in mammalian cells, in HEK cells and in CHO cells. BNP levels were measured in 40 samples from heart failure patients by using 5 different commercial BNP immunoassays. The epitope specificity of antibodies and standard materials of the assays are shown on this slide. Absolute BNP concentrations measured in heart failure plasma samples differed considerably between BNP immunoassays for internal calibrators and for 5 out of 6 external calibrators. However, when glycosylated proBNP expressed in HEK cells was utilized as a common external calibrator for all assays, a significant reduction of the between-assay variability was achieved. We observed that the different BNP assays were not equal in recognition of BNP, non-glycosylated proBNP, and glycosylated proBNP. These may reflect the differences in cross-reactivity of commercial BNP immunoassays for different BNP-related forms. 2 forms of glycosylated proBNP expressed in HEK cells and CHO cells were not similar. This apparent discrepancy may be explained by the differences in the level of glycosylation of proBNP expressed in HEK and CHO cells. We consider that the positive effect of recombinant glycosylated proBNP produced in HEK cells on the reduction of between-assay variability can be explained by the fact that glycosylated proBNP represents a major BNP immunoreactive form present in the circulation. The results of the present study show that recombinant glycosylated proBNP expressed in HEK cells could serve as a common calibrator for BNP immunoassays to reduce between-assay variability and achieve better comparability of BNP concentrations obtained by different commercial BNP immunoassays. This study may be considered as a starting point toward standardization of BNP measurement results. We suppose that further studies organized by standardization committees are needed to evaluate the potential of the suggested calibrator to become a common reference material. Thank you.